Energy is everywhere, but how fast is it being used? From sprinting athletes to glowing bulbs, let's break down the science behind power, one of the simplest physics terms, but also one of the most misunderstood. Power is the rate of doing work. It is also defined as the rate of transferring energy from one form to another. It quantifies how quickly energy is used or transferred from one form to another. It is measured in watts. Power is mathematically expressed as P is equal to W over T, where W is work done and T is time. It is also expressed as P is equal to E over T, where E is energy transfer and T is time. By the way, did you know? A horse can generate around 750 watts of power. That's actually where the term horsepower comes from. So yes, your car is powered by a whole herd of invisible horses. Let's consider some examples. A man lifted a 50 kg bag of cement by 2 meters in 4 seconds. Calculate the power used. Before finding power, we need to calculate the work done. Work done is equal to force times distance. The force in this scenario is weight, which is equal to mass times gravity. Then distance is height. So work done is equal to mass times gravity times height. The mass given is 50 kgs, gravity is 10 meters per second squared, and height is 2 meters. 50 times 10 times 2 gives 1,000 joules. Now we can calculate power. Power is equal to work done over time. Work done is 1,000 joules and time is 4 seconds. 1,000 over 4 gives 250 watts. Another example, a car has a mass of 1,100 kg. It speeds at 30 meters per second in 15 seconds. Calculate the power generated by the engine. First, we need to find the kinetic energy of the car. Kinetic energy is equal to half times mass times velocity squared. The mass given is 1,100, and velocity is 30 squared. This gives 495,000 joules as the kinetic energy of the car. Now we can find the power generated by the engine. Power is equal to energy over time. Energy is the kinetic energy, which is found to be 495,000 joules, and time is 15 seconds. This gives 33,000 watts as the power generated by the engine. Here's a mnemonic reminder. Power loves speed. The faster the energy moves, the more powerful the system. To recap, power is defined as the rate of doing work. It is also defined as the rate of transferring energy from one form to another. Power is mathematically expressed as P is equal to W over T, where W is work done and T is time. It is also expressed as P is equal to E over T, where E is energy transfer and T is time. Power isn't just about strength, it's about speed of energy. Whether lifting bricks or launching rockets, understanding power lets us measure performance with precision. Now that you've mastered power, get ready to explore the types of energy in our next video. Stay tuned. Stay curious.